All right, so now it's my turn to get going. So with logarithmic equations, okay, same thing. First step, you want to isolate it. So I am going to subtract 3 from both sides. That gives me negative log of x plus 2 equals positive 2. Then I still don't have it isolated. I'm going to divide by negative 1 on both sides. That gives me log of x plus 2 equals negative 2. Once I have it isolated, then I am going to switch forms. So this is in logarithmic form, so I'm going to go into exponential form. My base is assumed here to be 10 because it's not written. So this is 10 to the negative 2 power is equal to x plus 2. 10 to the negative 2 power is 1 over 100 equals x plus 2. Subtract 2 here. When I subtract 2 on the left side, I'm really going to subtract 200 over 100 because that's equivalent to 2. And so then that gives me negative 199 over 100 is my x. And what we did there was we solved.
These are the ones I was looking for.
This one is a little different because we have 2 logs on there. But knowing what we know about condensing logs, we can make this really be log of x minus log of x plus 4 to the 1/2 power. And that really then, that was applying my power property. Now I can apply my quotient property, and this is really log of x over x plus 4 to the 1/2 power. Okay? And that is going to equal 1. So now I've isolated my log by condensing it. Okay? So now I can switch forms, and I can switch this into 10 to the 1st power equals x over x plus 4 to the 1/2 power. Now I got to solve that. Multiply both sides by x plus 4 to the 1/2 power. But x plus 4 to the 1/2 power is really the square root of x plus 4. And so that's going to equal x. Then I'm going to square both sides. So on the left side, I get 100 times x plus 4. On the right side, I get x. Distributing 100x plus 400, this should be equal to x squared over there, okay, equals x squared. Forgot the squared part, my bad. Okay. Set it equal to 0. 0 equals x squared minus 100x minus 400. Now this is not factorable. Okay? So when in doubt, I can always use my good old friend, the quadratic formula. Okay? So that's going to be the opposite of b, plus or minus the square root of b squared. So negative 100 squared is 10,000. Okay? Minus 4 times a. 4 times a is 4. Times negative 400, which is c. So that's plus 1,600 all over 2 times a. So this becomes 100 plus or minus the square root of 11,600 all over 2. Now, square root of 11,600. So let's go a little sidebar action here. 11,600, that's going to be 100 times 116. 116 is going to be 4 times, what would that be? 2529. Okay? So the square root, this one, becomes 10. Oops, let me get into a different color here. This one becomes 10. This one becomes 2. And this one stays the square root of 29. So this is 100 plus or minus 20 times the square root of 29 all over 2. So here x then is going to equal 50 plus 10 times the square root of 29. And x is going to equal 50 minus 10 times the square root of 29. Now, logic tells me that the square root of 29 is a little bit more than 5. So when I do this down here, that's going to be 10 times something a little bit more than 5. Okay? Which is going to be something bigger than 50. So this is going to be a negative value. And the reason that that's important is if I go back to my original problem here, log of x, the argument has to be positive. So since this argument for this last one down here would be negative, this value gets thrown out, and the only answer that I'm left with then is x is equal to 50 plus 10 times the square root of 29.